So just a quick review of Bernoulli's principle was that the faster the air moves over an object, the lower the pressure. And the slower the air is moving, the higher the pressure. And so you did this quick little experiment here. We talked about the scientific method. And then we just finished watching this video here with the demonstrations. So two different theories of lift. So Bernoulli we talked about Newton a little bit as well. The two different theories of lift. Sir Isaac Newton and Daniel Bernoulli, they each have theories of how an aircraft can lift off the ground and how they stay off the ground. So both theories are commonly used to explain lift. And both are debated as the reasons lift occurs, but they probably both have the effect of lift. So Bernoulli's principle, it's a lift. That is the force that sends an aircraft in the air and holds it there. So Bernoulli's principle explains it with air pressure. The air pressure under the wing is higher than the air pressure over the wing. So the higher pressure underneath, it pushes the wing up and produces lift. Then we have Newton's theory, and his theory, airplanes fly because their wings deflect air downward so that the plane is forced upwards, because Newton's third law of motion states that for every action, there is an equal and opposite reaction. So Newton's law is basically saying that to generate lift, the wing must divert air down so that the plane can go up. All right, so a wing is created that's shaped to push air under it. The only issue is that you need a lot of air to be diverted down in order to generate lift. So that's why planes have to have really, really fast takeoff speed, as they need to push a lot of air down to lift off the ground.
The room. You're happy it works, but then you remember the wings of your paper airplane are flat. Obviously, it's made of paper. But aren't wings supposed to look like teardrops to work? No, not necessarily. So what's going on? Imagine you're a happy little wing minding your own business, but the pilot fires up the engine and now you're staring down a bunch of air molecules rushing straight towards you. You do your best to push back and push down so they move past you. This arrow represents you pushing back and this one pushing down. Well, these annoying buggers aren't going down easy, and they retaliate in accordance with Newton's third law of motion, which stipulates that for every action, there's an equal and opposite reaction. So these guys push back and up at you in the same magnitude but in opposite directions. Let's move these arrows so it's easier to see. The arrow pointing back is drag, and drag slows down the airplane. The arrow pointing up is, you guessed it, lift, and lift is what makes flight possible. The same happens when you get bored driving and stick your hand outside your window. When your hand is horizontal with the ground, not much happens. But when you angle it up, you can feel your hand being pushed up and back. It's the same principle at work. In reality, wings don't have to look like teardrops to work. In fact, there are numerous designs out there, including flat ones used for supersonic flight. So why do most wings look like teardrops? It's because engineers want to direct air above and below the wings in a specific way to suit their needs. When air molecules hit the wing, there's a point on the wing where air separates, one group going up, another down. This is called the stagnation point. Air molecules arriving above the stagnation point will be redirected tangent to the convex curve of the upper part of the wing. But that will create a vacuum between the air molecules and the surface of the wing, pulling them back. This is called the Coanda effect, and this is why air molecules above the wing follow the wing's convex curvature. And by doing so, air molecules above the wing are directed or pulled down by the wing. In response to this downward pull, an equal and opposite reaction by the air molecules pull the wings up. So the third law of motion acts to create lift not only below the wing, but above it as well. And that's how wings work to create lift. Stick science. Thank you for watching. If you didn't already know.
Alright, so next here we're just talking about what is aerodynamics. So aerodynamics is commonly used when we are discussing drag. It basically means we make objects that have a shape which reduces the drag from like air resistance and so on. So for example, in the video, if you turn your hand sideways when you have it out a car window, it reduces the drag from the air. And therefore the air can easily move past the smaller surface area of your hand. All right, so same thing with like planes. You can reduce drag by making aerodynamic planes that can cut through the air easier. So that's what aerodynamics is. So all planes will have some drag, which makes it important for engineers to calculate the amount of drag an airplane has so that they can adjust how much thrust is needed to overcome drag and keep the airplane up in the air. So engineers have to find creative ways to reduce drag so that airplanes can go faster and fly more efficiently. So the less drag an airplane experiences, the less fuel it will need to fly at the same speed. So the importance of drag slows down objects in flight, which is important for regulating speed and for landing. Skydivers, they use drag to slow down their falls so that they can land safely. Same thing with airplanes, and same thing with a parachute. It's another example of so with parachutes as well, it's another mechanism that produces drag so that falling objects can land safely. So drag is important. Weight or gravity, so that's the force of attraction that pulls together all matter. The Earth has this gravitational pull that pulls matter towards the center of Earth. It keeps us on the ground. It makes things that are in the air fall to the ground. And gravity is the biggest restriction for flying because, as you can see, humans are not designed to fly. Weight, it's the force of gravity acting to pull a plane to the ground, and the opposite to that is lift, which is used to overcome gravity and send the aircraft into the air. So the center of gravity is the point. Look at this diagram here. CG here represents center of gravity, which is right here. It's a point that would be possible to balance the aircraft if we suspended it in air. So basically that means there's an equal weight on both sides of the center of gravity. That's also called CG. It can also be called a balance point, and it affects the stability and performance of the aircraft. So it's usually on an aircraft, it's right above or below the center of lift. Otherwise, the plane will pitch forward or it might pitch backwards. It'll never stabilize. So usually the center of gravity is near the wings because it's the wings that lift the airplane. Effects of excess weight on an aircraft. So we talked a little bit about this last class. If there's too much weight on a plane, it will affect the performance of a plane. If there's too much extra weight, then a plane will need a higher takeoff speed, then it'll need a longer runway, a lower maximum altitude, shorter range of how far it can go, a slower cruising speed, and so on. So that's why airlines, they'll always have their luggage weighed so that they know how much weight will be on board the plane. Next is thrust or propulsion. So when we talk about propulsion or thrust, this is the force that moves the aircraft through the air. It's needed to overcome drag of an airplane and to overcome the weight of a rocket. So in aircraft, thrust is generated by engines. So a jet engine, it'll convert fuel into a powerful pushing force. And then, so what engines do is they create thrust by sucking in air through the front, and then they'll have an air compressor raise the pressure of the air. And then as the pressure rises, the compressed air will get sprayed with fuel to create an electric spark that will light up the mixture, and then the burning gases will expand and blast out through the back of the engine. And the jets of the gas will shoot backwards, therefore the engine and the aircraft will thrust forwards. The propeller generates enough thrust for aircrafts to fly. It's that spinning wing. That's the propeller. And it'll generate differences in air pressure between the front and back surfaces of the blades. And it will spin with the help of an engine, and they're shaped so that air pressure is higher on one side and lower on the other side, and that will help create thrust that moves the aircraft.